Hello, welcome to Data Science with EJD. In this video, I'll be talking about K-means clustering, specifically for customer segmentation. In the last video, I introduced the idea of K-means clustering, and in that case, when we implemented the Python code, a we used a synthetic data from blobs in scikit-learn, but here I'm using a well-known data set called the Mall customers data set. You can find it on Kaggle. So that's what we're using here. So introduction to customer segmentation. Customer segmentation is a process of dividing a customer base into distinct groups that share similar characteristics. Effective customer segmentation allows businesses to personalize marketing strategies. Maybe you discover young people come to your shopping mall and they buy a particular kind of product. So you want to you want to personalize their marketing strategies. Then you also want to improve customer satisfaction because these people, maybe some people, when they come and buy a particular product, they always like to buy something else in addition to that. Um, so you also want to think about that. So you want to optimize your product offerings and increase profitability and customer retention. So the question is, why use K-means clustering for segmentation? K-means is a widely used unsupervised machine learning algorithm that automatically groups data points into K clusters based on similarity. Okay, it can be age, it can be gender, or whatever. So advantages include intuitive, and that is simple, intuitive, and computationally efficient. It scales well to large data sets. It provides clear and interpretable cluster centroids, and it's commonly used for exploratory data analysis in marketing. So let's look at the more customers data set. First of all, I have it here, the more customers data set, which is available on Kaggle and other public platforms. So it contains I think about 200 data points and five columns. Yeah, 200. You have 200 customers with five columns. So you have customer ID, the gender, the age, the annual income, and spending score, like that. So those are the things you have there. So that gives us a kind of overview. So the customer ID is actually a unique identifier for each customer, just like we learned in under SQL. Gender is categorical variable for male and female. Age is numerical. So that talks about the specific age of the customer. And the annual income is in thousands of dollars. So customers' yearly income in $1,000. Then the spending score is 1 to 100. That's numerical score assigned by mall based on purchasing behavior, right? So the goal is you want to use numerical features like age, annual income, and spending score to segment customers. So first, let's talk about the data processing. First, the data cleaning. So you want to check for missing values and which you can handle or impute if any. Then you can also remove duplicates to ensure data set integrity. For feature selection, you may want to select age, annual income, and spending score. You can also exclude customer ID as it is just an identifier. You can consider encoding gender if you want to include it. That's for binary encoding. Then for feature scaling, K-means relies on Euclidean distance, hence scale features to a common range. Then you want to apply a standard scaler which turns the data into a normally distributed data with mean zero and standard deviation one. Then you can also use the min max scaler, uh which I think normal I mean there's this confusion between scaling and normalization. All right. Uh the min max scalar, these are two types of scalar now. The standard scalar actually turns the data into a normally distributed data into with mean zero and standard deviation one, whereas the min max scalar scales the data within range 0 to 1, for instance. So talking about exploratory data analysis, before clustering, understand feature distributions like so you may want to visualize histograms or box plots for age, income, spending, score. You can also analyze correlations, plot pairwise scatter plots to observe relationships. This informs preprocessing and cluster interpretation. So now choosing the optimal number of clusters, right? We already saw the idea of using elbow method or silhouette analysis. That silhouette score to know the optimal number of clusters. So you can plot the within cluster sum of squares or inertia against different values of k, e.g. 1 to 10. Identify the elbow point where adding more cluster does not significantly reduce inertia. I mean, we saw something like that in the previous video. Then you can also use silhouette analysis. Silhouette score measures cluster cohesion and separation. So scores range from -1 to 1. Higher values indicate better clustering. So plot average silhouette scores across different Ks to choose the best K, just like we did in the last video. Then we also have the gap statistic method, which can also be used to know the best number of clusters. So gap statistic is advanced. So here you can compare total within intra-cluster variation for different Ks with a null reference distribution. Then it helps to confirm optimal K. So K means clustering algorithm step by step. We've done this before, so it's just now using it on the more customers data. So initialization, you randomly choose K centroids. Then assignment, you assign each data point to the nearest centroid based on Euclidean distance. Then update, you will calculate centroids as the mean of all points assigned to each cluster. Then iteration, repeat assignment and update steps until convergence. Centroid stabilize or max iterations reached, right? So you keep doing that until you get all of that. So applying k-means to the more customers data. So first of all, you want to import libraries and load data. So import pandas because of course we want to work with data frame at some point. Then from scikit-learn preprocessing, you need a standard scaler to make your data normally distributed. Then from sklearn cluster, you need k-means, which is the model we are using. Then matplotlib and seaborn for visualization. Then for data preparation now, so you say data is uh, PD read CSV because the more underscore customers document is a CSV. So this data here. So you're creating a data frame from this. Then you can now select relevant features now from that X. Um, okay, so select relevant features like age, annual income, spending score. Then you can now scale the features now. So scalar standard scale. So just say X scale is now scalar dot fit transform. Then the whole X you have separated here. So you are scaling all of that. So we run this and then that is done. Okay, I forgot to run this. That's why we have, yeah, that's about being done. And then we can come back here. Now this just happens. So I forgot to run this. That's why we had error here. Then the next thing is to determine optimal K. You can use the elbow method or the silhouette score. So as usual, just like I said before, I put the first few lines to avoid a particular error I was getting. So, um, so this is to avoid MKL memory leak on Windows. Then this is also to ignore the error. So for the error elbow method, so you get something like an elbow, and once you begin to, at the point where you have the values not changing, uh, you can now know that's the maximum number of clusters you should have. So if you run this now, just like we did before, so you see okay, this becomes a little bit more complicated. One, two, three. So it's going, and I mean it's going all the way. So I don't know if we can say 6 or 7 is the right place for this because everything keeps declining like that. Maybe we need the silhouette score to further decide, right? So okay. So for the silhouette score now, I think silhouette score is clearer than silhouette score is clearer than elbow method. So for silhouette score, we can easily see that K should be 6 or something like this. So because this is the peak value here, it is at the sixth cluster or something like that. So but somehow here we finally choose 5. But okay, I'll work with 5 now, then maybe choose 6 later. So now we can outfit K means with optimal K, which e.g. 5. Actually, our optimal K here based on silhouette is 6. And just like I said here before, I was already looking at this 6. But this is clear, like it's clearly the sixth cluster, number of clusters 6. So, okay, let's work with 5 and maybe later 6 and then do all that. So we've done this in the last video. So K means number of clusters is optimal K, that's 5 now. So you add cluster labels to data. So we run this right, and then cluster interpretation and visualization. You have cluster centroids. So transform centroids back to original scale and examine. So you have scalar that inverse transform. So bring them back, and then you do this. So we have all this. So for age, we have 46.25, you know, annual income 26.7, and so on and so forth. So this reveals typical customer profiles per cluster. So, we have 5 clusters now. So these are the 5 clusters. The average age for the first cluster is 46.5, second is 25.1, third is 32.8, third, I mean, fourth is 39.8, and fifth is 55.6. So, and the annual income of people around this age, that's all you're seeing around there, and their spending scores too. Okay. So, in that case, you can now visualize their clusters by running this now. So now we have these are the five clusters. Okay. So the first set, that's 46.2, people around 46 in short. That's cluster zero. So these are these guys here. Okay. So you can relate with them together because they have some similarities. Then what about cluster one? Cluster one, the people around age 25. So cluster one, these are the guys here, people around age 25. Then for cluster two, the third cluster, that's people around age 33, 32, 33. That's two. So this deep green color. And then cluster three, so these guys are around 40 years, and they are this light green. And lastly, we have the yellow like this. So we have this. And just like I said before, right? Actually, the optimal value for a cluster we should have is 6. So we can go back to that 6 and see how it works. So run this, then come back here. Now we are going to have it up to 6. So now this adds a bit some finer details like that, and then we can have this now. So you have 6 clusters, so you have this purple, you have purple, blue, is it purple, lilac, and blue, so to speak, have been added now. So we have some finer details there. Okay. All right. So business insight from this segment. Example of possible segments we can have, like we've had this 0, 1, 2, 3, 4. So we can have, say, young, low income. These are just examples because from actually what we have here, right? 56, we have 56-year-old, 26-year-olds, and all that. But this is just an example. But if we want to drill into that data itself, we can look at the age and all that with their spending scores and their annual income and everything. So, yeah, that's how that goes. So if we have a cluster zero and they are young, low income, low spending, so in this case, the marketing strategy can be to promote affordable products and loyalty programs for this age range. And if you have middle-aged, high income, high spending people, maybe like VIP customer programs, exclusive offers because they earn high and they spend high. Then if you have seniors who have moderate income and they spend moderately, you can have tailored offers focused on comfort and reliability. Then if you have young adults with moderate income and high spending, so you can get market to them trendy new product launches or social media campaigns. Then for low income, low spending, you want to have budget friendly deals and discounts for them. So, that's what clustering helps you to know. So you can segment your customers like that and know what exactly works for them. So, limitations and best practices. K-means assumes clusters are spherical and equally sized, which may not hold in real data. Okay, I mean, understanding clusters enables personalized marketing, product design, and customer engagement, just like we've seen up there. So, limitations and best practices, like I said, K-means assumes clusters are spherical and equally sized, which may not hold in real data. So, it is sensitive to outliers. Consider preprocessing to remove extreme values. I mean, under data analysis with Python, we did something like Windsorization, where we beat outliers, whether too low or too high, into a particular acceptable range using some very a bit complicated mathematical stuff, right? So K-means only works with numerical data. Encode categorical data properly or consider other algorithms like hierarchical clustering or DB scan. So if you're not working with numerical data alone, K-means is not the best. So try multiple initialization like ninit to avoid poor local minima. Also, evaluate clusters with business knowledge for actionable insights. In conclusion, applying K-means clustering to the mall customers dataset provides a systematic, data-driven approach to uncover customer segments that share similar demographic and behavioral traits. This empowers businesses to develop targeted marketing campaigns, optimize product offerings, and enhance overall customer experience. So, clustering is really useful if you want to deal with a particular category, if you want to segment people and know how to, you know, deal with them in one way or the other, or if you, I mean, in the context of a church, even you want to do some kind of K-means clustering to see, okay, these are the people we have, these are the kind of things they like, and you can tailor certain things to make them get the best of the situation. So with this, I come to the very end of this video. Um, Let me know how helpful it is for you, and be sure to subscribe if you have not done that already. And hit the notification bell so you can always get alerted each time a new video is released. On my channel, you can become a member to get some special privileges. So feel free to click on join and explore the possible membership options. Um, you know, if you do, feel very free, to share this video with other people so that they can have access to this great content I have going on here. Till I come your way again, keep doing data right. Bye.